Hello everyone, welcome back. So in this video we are going to learn about circular convolution. So if you are first time to my channel, please consider subscribing. So circular convolution, so if the input x of n is there and the system impulse response h of n, so if y of n is there and if we want to find the circular convolution, so we are going to represent it as y of n is equal to x of n convolved with h of n. So if you want to find the circular convolution, then so we have to follow there are two methods. Okay, so there are two methods for finding circular convolution. One is matrix multiplication method, and the second is concentric circle method. So in this video we'll concentrate only on matrix multiplication method, and in the next video we'll discuss about the next method, that is concentric circle method. So if generally if x of n have m samples, suppose if x of n has m samples and h of n has n samples, then y of n, which is circular convolution of x of n and h of n, will consist of maximum of m comma n samples. Okay, so this is very important formula. Okay, you have to remember x of n consists of m samples, h of n consists of n samples, then y of n, the output of circular convolution, consists of maximum of m comma n samples. Okay, so this is very important. So now we will see the matrix multiplication method. So in matrix multiplication method, you are given with two sequences x of n and h of n. So we have to take the matrix. Okay, so matrix of x of n, suppose if you take x of 0 here, x of n minus 1, x of n minus 2, and so on, x of 2, x of 1. So after writing this, you shift one bit right. So when you shift one bit right, then the x of 1 will be shifted to right this side. So x of 1 will be shifted here. So this x of 0 will be shifted here, and x of n minus 1 shifted one bit right, x of n minus 2 shifted one bit right, and so on. So you will get here x of 3, and this will be x of 2. Similarly again shift one bit right, so you will get x of 2 here, x of 1, x of 0, x of n minus 1, and here you will get x of 4, and this is x of 3. So on, if you write it up to n minus 1, so this becomes x of n minus 1, this becomes x of n minus 2, and similarly x of n minus 3, and so on. This will be x of 1 and x of 0. So after writing this matrix, you have to multiply it with the impulse response matrix, h of 0, h of 1, h of 2, so on up to h of n minus 1. So if you multiply, you will get the output sequence, y of 0, y of 1, y of 2, and so on up to y of n minus 1. Okay, so this is the procedure which we follow in matrix multiplication method. Since it involves matrix, so this method is called as matrix multiplication method. So first of all we have to take x of 0 and the last sample, that is x of n minus 1, and the remaining samples x of n minus 2 and so on up to x of 1. Now shift each row by 1 bit right. So this x of 1 will come here, and x of 0 shifted right, x of n minus 1 shifted right, x of n minus 2 shifted right, and so on, x of 2 also shifted right, and again. So this shifting must be done until it is repeated. So if you do the shifting here, it will be the first column, x of 0, x of n minus 1. So we have to stop here. Okay, so this matrix when multiplied by the given impulse response matrix will gives you the output matrix. Okay, so next we will see an example of circular convolution using matrix multiplication method. Suppose if x of n is equal to 1, 2, 3 and h of n is 1, minus 1, minus 2, 3 and minus 1. Okay, so if this is your x of n and h of n, then we'll find y of n by using circular convolution, that is matrix multiplication method. Okay, so first of all we have to see whether the number of samples of x of n and h of n are equal or not. So in this example, the number of samples of x of n is 3 and number of samples of h of n is 5. So first of all we have to equate the number of samples of both x of n and y of n by using zero padding concept. So zero padding concept is the addition of zeros as samples at the end of sequence. Okay, so at the end of sequence if you add zeros, then that process is called as zero padding. So in order to make the number of samples equal between h of n and x of n, we are going to add 2 zeros at the end, and this process is called as zero padding. Okay, so after zero padding, now x of n and h of n are having equal number of samples. Now we can find the matrix multiplication method. So in the matrix multiplication method, here it is x of 0, this is x of n minus 1. So here n is equal to 5, so n minus 1, which is equal to 4. So x of 4 is 0. So x of 4 and x of 3, next x of 2 and x of 1. Now shift 1 bit right. So this x of 1, the last will become the first. Now last element of the previous row will become the first element of the next row. So x of 1, x of 0, x of 4, x of 3, and this is x of 2. Next here x of 2, x of 1, x of 0, x of 4, and this is x of 3. Similarly x of 3, x of 2, x of 1, x of 0, and this is x of 4. Next is x of 4, x of 3, x of 2, x of 1, and this is x of 0. If you shift again, so it will become the first row. So we have to stop here. So this multiplied by h of 0, h of 1, so on up to h of n minus 1, that is h of 4, h of 2, h of 3, and h of 4. So if you multiply, it will give you the result y of 0, y of 1, y of 2, y of 3, and y of 4. Okay, so if you substitute the values, what you'll get? So x of 0, this is x of 0, 1, 2, 3, and 4. This is h of 0, 1, 2, 3, and 4. Okay, so x of 0 is 1, x of 4 is 0, 0, 3, 2. Next 2, 1, 0, 0, 3. Next is 3, 2, 1, 0, 0. Just shift 1 bit right. Okay, so 0, 3, 2, 1, 0. Next 0, 0, 3, 2 1. Okay, so this is the next. Okay, and now 1 minus 1 minus 2 3 and minus 1. So just multiply the first row with this column, then you will get the first value, that is the y of 0, that is we'll get it as 8, because 1 into 1 is 1 0 0 and 3 into 3 is 9, 1 plus 9 is 10, 2 into minus 1 is minus 2, so 10 minus 2 is 8. Similarly, if you proceed, second row multiplied by this column will gives you the second value, that is y of minus 1, which we will obtain it as minus 2. Similarly, the third is minus 1. If you multiply the fourth row with this column, you'll get minus 4, and if you multiply the fifth row with this column, will give you this minus 1. So y of n is equal to 8 minus 2 minus 1 minus 4 minus 1. So if you observe here, the given input has 3 samples and the impulse response have 5 samples. So in the output, maximum of 3, 5. So maximum of 3, 5 is 5. So there are 5 samples in the output. Okay, so this is how we can find the circular convolution using matrix multiplication method. Okay.